Okay. So from last chapter takaita zvana masi zvema-SI unit zvese ana mass ana force tsvaka ma-derived nema-SI unit. So correlation takwenda pa force force takaitsvaka last time takaitsvaka kana force toiwana tati mass times acceleration. So now takuenda kuna force matsvaka weight nemass timbona kuti chii ichocho. So since force takaita pa last chapter takukontinua tuchienda pa weight. So what is weight? Weight uremu hwechinhu. So weight is the force acting on mass due to gravity. So gravity is just the gravitational force. So another definition, you can say it is the pull of gravity on the body. Okay. So weight, it is measured in newtons using a spring balance or a force meter. So weight chii chinoshandiswa kumeasure weight is a force meter or a spring balance. Then my units acho is my newtons. Okay. So don't confuse weight and force. Right? So weight is measured using a force meter, and you can also use a spring balance. So totsvaga say weight is just mass times gravity. So unongapa gravity wapiwa mass yacho ichinhu chacho unotsvaga weight. So weight is mass times gravity. So the unit of that is in newtons. You can simplify W equals to mg, which is just weight equals to mass times gravity. So gravitational, alright, the gravitational force, the gravitational field strength near the surface of the earth is 10 newtons kg, something like that. Okay. Therefore is a mass of about 100 grams. So 100 grams is 0.1 kg. Is a weight of just less than up. Alright, I'm going to description. So up. So chinhu chedu chine gravity 10, then in a mass of 0.1 kgs. So kuti titsvake isusu kuti tsvake weight yacho is just mass yacho, which is 0.1 times 10, and something which is less than 1 newton. Okay, so seems like it makes sense. So there's some differences between mass and weight. So there are the differences between the mass and the weight. So mass is a measure of body inertia. Then weight is a force acting on mass due to gravity. Okay, so this table just self-explanatory, I think. So then mass is measured in kilograms, then weight is measured in newtons using a spring balance or a force meter. Okay, then mass inodependa neinertia, then weight inodependa nemass. Okay, weight inodependa nemass, then mass inodependa neinertia. Mass is independent of the position of the body. Then weight inochinja, so it varies according to the gravitational field in which the body lies. Okay, then mass is only magnitude in no direction. Then weight is both direction and the magnitude. So these are differences. So ungobata like that. Then you go through inertia. So that mass inodependa neinertia. Then what is inertia? It is the property of mass which resists change from its state, rest, or run from motion. The inertia of an object refers to the reluctance of the object to start moving if it is stationary, or reluctance of the object to stop moving if it is moving in the first instant. So that's inertia. So mass inodependa on inertia. Okay. Momentum. So there's something like momentum and inertia. You must know, or you must be able to define these two things. So momentum, what is momentum? Momentum is the product of mass and velocity. So momentum to one that mass times velocity. Okay. So don't confuse momentum and force, because the force is mass times acceleration. Mass times acceleration. Momentum is mass times velocity. So there's a difference between acceleration and the velocity. Okay. So momentum is defined as the product of mass and velocity. It is a measure of the object resistance to stop. Okay, that here. Alright, that is an example. Okay. So, for example, the body has a mass of 2 kg traveling 3 meters per second with a momentum of 6. Just mass times velocity. So it's 2 times 3, which is 6 kg meters per second. Like this one. Self. Okay. So there are things like you must know which is Newton's law of motion. So Newton's law of motion, we have three different or three laws of motion akadiscover namunhu ayonziwo Newton, that clever guy Isaac Newton. Okay, so first law of motion it is also a body will remain at rest or to move with a constant velocity unless acted upon by a resultant force. Okay, a body will remain at rest or to move with a constant velocity unless acted upon a resultant force. Zvaari kutaura ndezvekuti chinhu chogona kuramba chakagara pachakangogara, like bhara wakarisiya rinoramba riripo unless someone auya ambarisunda. That's it. Kana kuti bhora rakakaviwa rinogona kuramba richienda unless rovira pamwe pano oro radeflectwa nechimwe chinhu. That's what this law says. Okay, the first law tells us two things. If there is no resultant force acting on an object at rest, the object will remain at rest, and if there is no resultant force acting on a moving object, the moving object will continue to move at a constant speed in a straight line. Okay, I think zvabatika pa first law of motion. So pama applications acho ndataura zvebhora ndataura. So there are different applications, like you can read this one, just let me go through it. So drivers need to wear seat belts when driving because of the effect of inertia. Without the seat belt, if the driver suddenly applies his brakes, he will continue to move forward due to his inertia and crash into the windscreen. Okay, that's the application of the first law of motion. Slide a glass full of water across the table to the right. The water in the glass will seem as though it is moving to the left of the glass. This is the result of inertia. A ball will remain stationary forever unless moved by some external force. So apa akangotaura kuti bhora rogona kuramba riri pariri ipapo roramba riri pariri unless someone auya akarecover. Otherwise bhora rogona kuti takarecover rogona kuramba richingoenda unless rovera pane something. That's what this law says, the first law of motion. Okay, then there's this second law of motion. It says the acceleration of mass is proportional to the force on it, provided the mass stays the same. This second law of motion takaita zvemaforce guys, so iri kungotaura zveforce. Force yatakaita pafirst topic iya tichiti force equals to mass times acceleration. So ari kungoti iyo acceleration, the acceleration of mass, or what mass times acceleration is equal to the force. That's what this law says. It's all about the force that I'm going to face it per first chapter. Okay, so the acceleration of mass is proportional to the force on it, provided the mass stays the same. Okay, Newton's second law tells us that when there is a resultant force acting on an object, the object will either slow down or speed up. Okay, when there is a resultant force acting on an object, the object will accelerate or decelerate. So in other words, apo nyaya iri paacceleration apo takawedzerawo force chinhu chedu chinomhanya, takadzikisawo force chinhu chedu chinodzikirawo speed. That's all about this. So kungodhilanana F equals to ma, this force equals to mass times acceleration. Okay, so there's this third law of motion. Action and reaction are equal and opposite. So guys, first law of motion, an object can continue to rest, or an object will remain at rest or move with a constant velocity unless acted upon by the resultant force. Then the second law, not as acceleration. The acceleration of mass is the proportion to force on it. Then the third, action and reaction are opposite and equal, or are equal and opposite. Okay, what does this say? If body A exerts a force on body B, then body B will exert a force on body A of equal magnitude but opposite direction. Force acquires in pairs, action force and reaction force. Okay, the action and reaction are equal in magnitude, act opposite to one another and act different on different bodies. So nyaya iripa, I can give example vanhu two, one akuda kurova umwe neumwe ari kuda kurohwa. So these are two things. Munhu akuda kurova umwe ari kuisa force kune umwe, then akuzwa force anoreactawo neamwe mareactiro. So mareactiro avanoita akafanana asi akasiyana, like uya akuda kurova umwe, uya akuda kudzorera. So action iripo nereaction iripo zvakafanana, are the same or are equal but zviri opposite. I think zviri kubatika this way. So force occurs in pairs, IA, or that is action force and reaction force. The action and reaction are equal in magnitude, which is size, act opposite to one another and act on different bodies. Okay, application. Let's consider this. A high jump will exert an action on the ground, which reacts by causing the jumper to spring upwards. So kana munhu arada jumper pa jump, there's an action inoitika, and like panotsika paipai pane zvinoitika panotsika, then panotsika achinojamba mudenga. So matsikiro anoita like force, like ngadescribe nechiti action yaanoita ndo inomupa power or the reaction yaanozoita achienda mudenga. Yeah, something like that. So the second application is, as birds push down on the air with their wings, the air pushes their wings up and gives them lift, thus making it possible for them to fly. Okay. So pakubhuruka shiri panenge achibhuruka, mapapiro achiisa mumapapiro mudenga achiendesa mapapiro pasi, like there's a force iripo, so pakuenda mudenga nepakudzika pazasi, so there's an action and reaction iripo between the wind and the bird, which force it kuti chibhuruke chiende mudenga. So the other application, a fish uses its fins to push water backwards. The water reacts by pushing the fish forward, propelling the fish through the water. Okay, so fish panenge ichiswima, kunonzikuita sei, iri kupushira mvura kumashure, then mvura iri kupushirawo fish kumberi. So there is two things, which is action iri kuitwa nefish, then reaction iri kuitwa nemvura. So action iri kuitwa nefish, simba rairi kuisa ipapo riri equal to reaction ichiitwa nemvura, but zviri opposite, because fish iri kusunduta mvura kumashure, iyo ichienda mberi. So that's what the sense comes from. Okay, the last application is the baseball forces the ball. The baseball forces the ball to the left, and the bat forces the ball to the right, like basketball chair. I can't describe this game, like I don't play this game. Okay, but I think you get the sense. Like, baseball rikuoposa direction nebhora, bhora rakakandwa, baseball rova, so there's an opposite and an equal action and reaction somewhere there. Okay, so thanks guys. So go through these notes. Wakana see now, you can contact me pa number apa nondakupa manotes. So you can also join our classes. My online class is cheaper, very very cheap, and you can start and you can get your A's, distinctions in this combined science lesson or combined science subject or level. Thanks guys for supporting. Thank you.